Welcome to the May meeting of the currently San Francisco Dynamo user group. My name is Brian McCaffrey, and we've got Daniel Segraves here up from LA. And so I'm just going to go through a couple of announcements really quickly. So if you're new to the meetings, online or here, and most of us I think in the room aren't, but for anybody online, you can sign up to monthly announcements at sfdug.org. You're all muted, so if you want to send us any questions during the presentation, just shoot us a chat or a question and we will get to it. And then I think there'll be some time at the end as well. And as I mentioned, Daniel Segraves is here from 2T down at Core Studio in LA. So a few things first. We've got some new announcements, exciting announcements.
Hi, my name is Young, and I'm a committee member at San Francisco Dynamo user group. We have been working on a new website probably since last December. And we are about to launch in a month. So you're gonna go to same website, like it says WordPress here, but we are going to integrate into existing website. Here's our new logo, and just same contents, better graphic, greater features. You will see like on the side menu that has updated and all that. So to go to our older post, all the existing link would work seamlessly. So stay tuned for new website. And our YouTube channel hit 1,500. Yay. So continue watching, and we also have other social accounts, but so far the YouTube has been doing great and the best. So visit us on Facebook, Twitters and YouTube, and continue hitting, good numbers. Thank you. So with that, without further delay, Danielle.
Oh, there's a couple of, sorry. Oh. Really quickly. So we've got a few events coming up, and I've added another one, but basically AU. So if you want to speak at AU, go to that link, and we can, especially if you got ideas, you want to collaborate. There's a lot of really awesome people in the room. And so if you have an idea about something you want to present, I think that's a great opportunity to do so. Get them in. And Intel AI at DevCon 2018. So this is basically in next week. Really cool stuff happening there. Just going to blaze through, but you can go there for more information. Similarly, Python stuff, crash course, beginning of June, and additionally, the symposium on simulation at TU Delft. So that's in about the same, like 3 weeks or something. So all this stuff is coming up really quickly, and you can go there for more information. The Hackathon and Symposium 2018 is beyond AAC. I'm sure actually several people have been involved in the room in this before. So that's also coming up of just a few weeks later. And additionally, this is a little bit further into the future than I think SASAR usually goes, but the prices are kind of like going up every week or two or whatever. And SASAR, he hasn't mentioned it, but he's speaking there. So I figured I'd throw it on and also throw him under the bus. So he's on that Tuesday, July 24th, talking about how you can sort of add value and get buy-in. The next meeting will be June 13th in about 3 weeks or so. Samuel, who was on chatting with us a lot last week, I haven't checked if you're on today, but he'll be speaking out remotely from Mexico City. Again, as always, thank you to HOK for providing all of the equipment, and Gensler AIA for the space, and Ideate for the food. And now, apologies, without further ado, we're going to hand it over to Daniel here.
that title was Cesar, so I didn't make that re-engineering computational design. So I'm with Thornton Tomasetti Core Studio. If you don't know what that is, it's our it's sort of our incubator for research, but more importantly, the center for our computational modeling and our application development. And it's sort of the center of all of our practices. That's the idea behind this. And we do a lot of these things. I mean, many more things than just the typical engineering. Structural engineering would do renewal and property loss and facade engineering. That'll make sense later when you see some of these projects are not exactly structural engineering. And I had this slide in there to make the point that we're a big firm, we're everywhere. And I'm not saying that to sell TT, but to explain that not all this work is mine. I couldn't fill an hour or 45 minutes with my own Dynamo work. It's not that interesting. It's not interesting enough. So it's a lot of other people's work. So forgive me if I stumble on any of it, but I know it somewhat intimately. This is Core Studio. We've got a lot of us are developers, and a few of us are more modelers, which is kind of what the work you're seeing now, the Dynamo work. And with a few, and I'm going to mention a few tools that we've developed that are Revit tools, but that's like a whole other presentation, all the stuff that we've been developing. And then we have Construe, which is that break-off, which is interoperability software that you may or may not have heard of, but I'll show a little bit about it. More on Core, I don't need to talk too much, but this is the different arms of the development stuff, like some in automation, some in visualization, some in interoperability. There's these different sort of wings of work. But so I'm just going to jump right in. This is perhaps the most in-depth one that I'll talk about, and the one that's I think's gotten the most traction in our office, which is it was a very simple, low-hanging fruit in a way, and that's what kind of Dynamo is good for. This is our RAM concept to Revit Rebar. RAM is a structural software that we use. It does floor design essentially, and also does rebar design. What you're seeing is on the right is the rebar placement by the software once it knows the loads and whatnot, and knows what if it's PT or whatnot. And so we need to get that into Revit, into a structural drawing, but we're not going to get in every single line like that. RAM also simplifies it with the sort of one line and an extrapolated text, which is normally how the plans work. But the process is not so direct. It usually goes from this to an engineer who then is sort of simplifying and extrapolating and making assumptions. And that markup goes to the modeler. We have dedicated modelers in the structural engineering practice, which is not as common in architecture, but perhaps more so now. And then eventually the modeler or the drafter is creating these drawings from that markup, and it's a kind of dead one-way process. So we use Dynamo to create the sort of direct connection and also in a way a loop, so that you can just go straight from the analysis software into Revit, which would be an obvious benefit, and makes that so much faster. You can imagine how long it takes to go from this to that, and on every floor, you know. So that was a low-hanging fruit, we should call it. And I want to mention that a couple of the things I'm presenting are like starting from Dynamo and then ending up as a custom tool that was then later developed further. So this is a great example of one. Dynamo becomes the excuse me, proof of concept place where you can mess around and it's loose, and then later we push it to like the developing guys who actually program it, make it a Revit tool that's built in, and you don't touch Dynamo anymore, which I'll show later. But there's a couple instances where that happens, and I think it's a common flow. It's like you test it with Grasshopper first, and then you test it with Dynamo, and then you perhaps make a solidified tool from it. Or there's a workflow from Grasshopper to Dynamo. There's a lot of those you'll see, because it's so much lighter for optimization. So the output is a database which has coordinates and other markings, like what the rebar size should be and at what spacing. And so there's your Excel file, and that's a simple import into Dynamo. And I thought, so I figured you guys knew Dynamo, or at least wanted to, and you wanted to get into the guts a little bit, because it's the user group after all. And so I thought I'd talk just briefly in some places about the actual components that we're using, or at least like medium level in the components, instead of just only higher level stuff like we did this and this. Like, so for instance, here's the inputs. It's pretty simple. You're getting your file path, and it's then sorting through Excel. And then the first part is you make the component first. You guys probably know that. You're instantiating the family or the detail or the tag. And in this case, the detail component, that part is a Python script that is taking the curve that you made and placing it into a detail element, and getting the right, I forget what this part is doing. Yeah, anyways, it's a script. So not everything is just, a lot of us find it, when, Dynamo is so clunky in some ways, sometimes when you're like banging your head against the wall, it's better to just code it, because for instance, it's hard to do like this. These if statements are quite hard to do in visual coding in general, like in Grasshopper as well. And loops, of course, we're in a while loop, we're in 2 while loops here, are really, visual coding just doesn't lend itself to that sort of thing. So jumping into Python is way easier. And then the thing is, the first step was putting the families and the components, the elements in there, and then you modify them, then you give them their data. So here we're giving them their tag names and all that extra data. I was saying the rebar size, and it's somehow filtering it out of the Excel and applying it, which is so elements set parameter by name. You probably know that one if you use this. You use that a lot when you're getting into Revit. So final result, a building like this, there's your plan, and it goes, for every floor you have to do it. For Dynamo, for this one you have to do it every floor, but it's so much faster. It's saving weeks of work essentially, more if you multiply it around the firm. And so it was obvious that we should make it into a tool, and this simplifies it much more, because you have, looking at like say the Dynamo on the left versus this is the interface for the tool on the right. It's so much simpler, and engineers in our office can use it without having to worry about be intimidated by this, or you have to open that up. So and then in this case you can do the whole building all at once, which is also way faster than even before. So this allows you, and that's made in Visual Studio, and this particular code was I forget what that was doing now. Oh yeah, it's like sorting through the points and placing the line first. And there's a lot. There's all these families. It's a few weeks of work to make that tool, but I think the payoff is pretty obvious in this case. And we have we always do this with the tools to prove their viability. The user statistics so far, we collect statistics for all of our tools, are 2 point. So I guess that's not time saved, but that's how much time it's been used. It's not that useful, but it's this many things have been drawn, and I think if you multiply that by how long it would take to do it the normal way, you'd get probably something like 200 hours or something like that. That's what's missing in this graphic actually. So I'm just going to go through a lot of little, so we just use Dynamo for all these little fixes here and there. You guys are probably the same. I'm just going to go through a bunch of them. A lot of them are translation, they're building, they're different things. This is eTabs to Dynamo into Revit. Construe works really well for all this, but sometimes there's, this is either before Construe that I'm showing you, or it's more custom stuff that, in fact, I know this is custom because the walls are canted and twisting a little bit, and Construe wasn't dealing with that at the time. What was I going to say about this? eTabs is another structural software that we use. It's framing and floor design, and it's good for towers. So same thing, you're like exporting. I think this is with Rhino, getting the lines in, recreating the curve, wall by face, recreating the wall like wall by face, and or you're getting the individual panels that you had there. Then eTabs, you can see they're like built in, and then building your curve larger so it's a more continuous wall, and then wall by face, and there's a slight amount of twist in it. Yeah, and then apply a curtain system to that. And then for the core of that building, you're doing walls, but you need then applying thicknesses, and you can see that output from ETABS has, these are the thicknesses, you're having different thicknesses throughout, and so like grouping them and then applying them with Dynamo. I think I have a video of that, but these videos are often a little bit slow, so I might jump forward. So there's your ETABS model, different thicknesses. Send it to Excel first to get for the thicknesses, and probably I think Rhino for the geometry, and then we're importing those thicknesses and applying them, like, and grouping them. Yeah, so that's the simplified version. But a kind of what would have been a fairly complex task, slightly simplified in Dynamo. Same for pier design. This one, the one that I'm showing here, that's a little more, you could of course do that with other transfer methods, but Dynamo just speeds it up with the assignments and things. I think Construe can basically handle this now, but that again is a sort of proof of concept that we then build into other softwares. That's how a lot of these work. This process works. Custom pier inputs. In this case, there's a bunch of different sort of parameters and tags that go with the pier. This is the final plan that you need in Revit. So you got a few different parameters first that you have to design for, and then that end up in the tags. So there's what that ends up looking like in plan, and there's a few different parameters that you need to get into the design software, which is actually in this case an Excel file. There's a couple instances, especially with like axial loaded things, columns and piers, that we just use a very complex Excel file to design them. So basically, we're making the building in Revit, and then with this custom pier family that has all these parameters in there, and then exporting that to Excel. So this is all like sorting it for Excel. This is the the different headers, and then using Excel to then design the pier with the thickness and length, or perhaps just thickness and rebar count, and not rebar, and then importing it again, and then applying that to that family, instantiating that family, or then setting the parameters again for that family that was already there, and then so that updates the tags and gets you your drawing that you needed. Using Navisworks, using clashes, like designing Revit penetrations with the Navisworks clashes. So there's your clash detection in Navisworks. There's HVAC and plumbing. Put those together, and we've got to design these openings in our our shear walls or any of our concrete. So it's basically you're building them in Revit. You go into Navisworks, and through Dynamo you go back into Revit and adjust the concrete model after that once you get the clashes. I think there's a video. And the Navisworks imports were custom tools that I think are probably are out there. And then Bluebeam to Revit. This is just another example, like how we have the engineers are making these markups, and it takes time for the modeler to then put them into the Revit file. So we could just automated pull in so the drawing started in Revit, right? That's on the left, and then an engineer marks it up in Bluebeam with these tags, and then with Dynamo we can then bring in the tags and apply them to the actual detailed drawing, and even draw the like leaders and stuff as they were in Bluebeam, though of course Revit treats the point-to-point different, and some of the formatting is different, but that speeds up things a lot, and like takes less work for the modeler, and then the engineer can just sort of it's a lot like looser way to work. You don't have to always be in Revit. I think a lot of these are about like getting out of Revit, like simplifying that whole thing. I think this was a video, but again, it's probably just what you've already understand. And the Bluebeam import was a custom thing we had to write. One of our sort of like Revit API guys figured out the blue beam thing. So you're calling that file, and then you can imagine what this is doing. And then there's revision clouds too. Yeah, so there's the cloud. Yeah, and that was this one is just showing revision cloud placement as well. And then taking that a little further into actual modeling, mark up a plan. In this case, all we had were like, we had the structural plans, and we know that we needed a new beam system in these areas. We had a Rhino model and not a Revit model. So we're bringing in from Bluebeam these frame design drawings with sizes, I think, and then bringing that into Rhino, and using that to project it to the surface that's needed, because you're starting with a 2D, and in Dynamo you're 2D, and then going to Rhino for the projection, and then back to Revit. I think that's a video as well. Back to Revit eventually. But you're using, in this case, we're using Rhino, so that was sizes, and then in this case we're using Rhino to kind of check the model as well, like against an existing Revit model. So there you're seeing the nude beams are over there, and then these existing beams are changing in shape a little bit. So and there's the roof surface. So we're comparing, and then we'll go back into Revit with Rhino again. So so there you're seeing it come back in, I think we were matching these, or finding similar and then adjusting them so it's not doubling up on those beams that existed already. I don't know if you guys have ever used MasterGraph from Dynamo Studio. We were using it to get, we wanted to get a database of carbon footprints for all of our buildings. And again, this is now like its own kind of data mining tool, but initially we're testing it with Dynamo by using MasterGraph, and then it has its slave graphs that are, the MasterGraph is going through, is telling it where every Revit file is for each project, and then the slave graph is then like querying that project for like steel amounts and concrete tonnage, concrete volumes and that sort of thing. So this is the master, and it's like looking for the folder and writing the journal that those do, and then the slave graph, which is looking through the model for like total steel numbers and compiling that all, so you get like total volume or area of, say, concrete. Of all, in this case, it's all these different kinds that make it kind of harder. And I guess this is by floor as well, or level. And then we were just looking at all that data at the time in Power BI, but we've turned this into what we call Spotlight, which I'll show you later, which is a like a data querier for Revit models. So you kind of, you really understand what all your quantities are, because Revit's not good at visualizing all that. So we made that little tool. I'll show you that later though. What was this one? Oh, this is just another thing where, just a quirky thing we're using. We're using Rhino to create the unroll, so we can make a drawing of the unrolled shape here. I mean, we're also making the diagrid in Rhino, because you start with that spiral, make the diagrid, make a few different instances, and here we're showing it to the client, I think, in Spectacles. Well, sorry, Mirar, which is what we call it now, which is an easy way to share BIM models. I will show you that again as well later. But then bring that into through Dynamo, and then apply it and get your unrolled. The important part is this part, the unrolled thing. It would be too hard to do that in Dynamo, at least we hadn't figured that out yet. Unrolling is so much easier in Rhino. And there's the sheet with that drawing, which would be hard otherwise. Complex massing. This is a funny one. Again, I know I've been doing this a lot, but we're going from Rhino into Dynamo. So you're doing a lot of the processing in Rhino. For instance, like breaking this up, where you have these old school drawings, and then drawing the structure, breaking it up to its sections that are needed. And there you're like creating the mass in Revit. But now once you have it in Revit, you can do a lot more, and it would have been, I mean, you could have perhaps extruded it somehow in Revit, but easier to just go this way. And then you can make your drawings from there and visualize it. And another case, sorry for this starting to sound repetitive, but we're optimizing in this case the form finding in Rhino, and then in this kind of a live link with Revit or Dynamo. So we're optimizing this roof form, this fabric minimal surface roof with Kangaroo in Rhino, and then or Grasshopper, and using that. Well, we're optimizing that for different tensions and forms and how much we know the deflection is going to be. So then changing the form, and then bringing that into Revit with Dynamo. That's just showing with it, which is like a NURB surface from curves, I think. And then we were using that. Well, so there's just the final thing. That's just easy way to get those surfaces in there and have it kind of linked. I think this was so that we can play with, which we're doing a lot as we're testing this in other software, Strand and whatnot, which gives us new parameters for Kangaroo. So playing with the shape, and then I think in this case it was a little less than like a dynamic live link. Bring that in through Dynamo, and then rebuilding the surface with the NURB surface, I think.
Can you explain this process with me? So the testing at per tensile strength is still done in other software.
Yeah.
But what are you doing? How are you optimizing it?
The Kangaroo is just we're just adjusting like the parameters based on, or we kind of know what the geometry is in Strand. That's Strand 7, and then using Kangaroo to match that, because it's a lot easier than going from Strand to Revit. So we're sort of recreating it based on like what we know will be the like depths and curvatures, because it is a good approximation of minimal surfaces with and has with various tensions, because you're basically fighting one tension against the other because it's a anticlastic surface, and that'll get you what you arrived at in Strand. Yeah, so that's why that's sort of a bypass. Otherwise, you'd just be importing like a dead DXF. So yeah, that's what that solved. And then we were doing and doing many iterations that way, which is helpful. And then this is again our what we call Mirar now, which is viewing, or we could send these very lightweight models on the web just as a web page to share, instead of having like open a Revit model to look at something. And then we were doing line of sight analysis. This is we did more complex ones. This is not the generative ones you're used to. Probably this is more just an analysis of blockage. But in this case, like the one we're seeing in Dynamo, I think it's just like we're just coloring it by vector length, or by site length in this case. So that's kind of a simple one, but that's also possible. I'm blowing through these. Another one, just all these quirky little uses of Dynamo that I just wanted to share. Another one, we're looking at topo, and we wanted to see how much soil was moved by this particular building. And for some reason, this is not me, but Hiram wanted to do it in Dynamo. I think, because the building was already in Revit, and he didn't want to like bother bringing it into Grasshopper, though of course I would have done it in Rhino. But here's your building that's already in Revit, and then you're getting you just have to create a volume from it. And he made this very simple soil volume that he got these points from the geological contractor, subcontractor, and then use that to make the surface, and then you extract your volume using Dynamo like a Boolean, and that gives you the number. Just basically, the contractor wants to know the number, the cubic feet of soil that they had to move. That's what they'll calculate their cost from. This is a fun one, more recent, a little more applicable to structural engineers, but visualizing demand capacity. That's usually something we do on existing buildings to make sure that if we build something on top of it, that the existing columns can handle it that they have capacity for the new stuff, or just, which is what our forensics practice does, or property loss, to make sure that the building, even as design, can handle itself if they perhaps change the equipment, or if something went wrong and they want to test that it was designed correctly. So in this case, you start with the building in Revit. Here we're going to construe and then bringing that to RAM, which will help us design, or rather get the loads on each column and the capacities. Or no, we know the capacities. How does that work? Well, here's the outputs from, yeah, RAM will give us the loads and capacities. There's your output, and then we just bring that back into Revit and visualize it. And it's a very simple, useful visualization. So you have the red is the load, current load, or new load, you could call it, and green is the capacity. So wherever you don't see green surrounding red, you know, olive shape, means that the red has exceeded as the green, which is capacity. You know, and I have a better example of that. I think this is, again, like I was saying, we start in Grasshopper as a proof of concept. Sometimes then we maybe do it in Dynamo later, and then it becomes a tool. That's like sometimes the life of these like processes. So I think this was Grasshopper. Anyways, playing with an existing building. I'm gonna pause this so I can explain it before it goes too far. Existing building on the bottom, building a new one on top. Playing with configurations for the architect to know what building shapes they can use. Of course, you wouldn't be playing with a form like that. You'd know what your core depths were, but you can see a live loading diagram over here on the left of that pimento olive thing. It lets you know when you've exceeded it. So in this case, it's never, I think, it's always, this is, you know, an old industrial building with big columns, and it's has a lot of inherent capacity, so it never really exceeded it, I think, unless you got higher floor heights. Yeah, as you get these higher floor heights, you're starting to approach it where the core hits the columns. You can see these middle ones. So yeah, anyways, that's a really useful visualization for the engineers to have in Revit, and to even include in a drawing that they then, like this is shared with the client, so they can know if it's working. This is a funny one. This was research that one of our core people was doing on. This is really a research on using Revit for data visualization, but it happens to also be about active shooter analysis, and he's using NetLogo, which is a agent-based, you know, modeler for a couple things, but also for this. And this is a really weird thing to talk about, but the output is these scatter plots that don't make a lot of sense. If you look at them, you inherently don't really know, but he's trying to make it related to the model geometry, which is this, so that you can compare options. So like there's doors were placed in this one, and he wants to compare like how the two frame up in the simulations compare. So he wants to have the dots, like you saw in that first image, on the model and sized according to their hit count, which is what comes out of the analysis based on the placement of the shooter. So the kind of success of each location, or not success, whatever the word is. So you make a custom family that then you can then populate with parameters later. You know, this is a common theme now with Dynamo. And you're just seeing there, you're setting the size and the color coding based on the output from NetLogo. There's your family, you know, find the family. This is a little more in the guts, but this is pretty simple stuff. Processing the Excel data, you know, removing the headers and like applying the XYZ columns. And then what was that one? Yeah, place the sphere, set the parameters, scaling it. This is all really simple stuff. Scaling it by the hit count, and then sizing it that way and coloring it, and then getting these much more usable data to look at, because now you're seeing how the geometry is affected by the, or rather it affects the situation. And even more so, scaling the, first of all, filtering. I love this view filter where you can say take out everything below 20, so you see the worst cases, and compare. Yeah, well, there's just see one comparing. Yeah, so this is filtering it, which is a nice way to see where the worst cases are, and you can see the situations are worse than the longer ones, and then comparing to two models where one has exits on all the rooms and one doesn't, and there's a big difference in the the data. All right, so I said I was going to talk about some of the application developments. I've gone through this faster than I thought, but I'll just go through these at the end. Mirar is our, which is what Spectacles turned into, which was, I think, again, this probably started in Dynamo, I think. It's our lightweight web viewer for BIM models, and now we actually use it for basically all of our models, like all of our analysis models and BIM stuff can go into this web viewer, which then can have an embedded link that can be sent. Not only that, but so you don't need Revit to look at the files, which is really useful if you want to share stuff just to see it quickly. And the other thing is we're now using that to kind of be the home base for all of our visualization for the analysis results, which I don't think I have a great. Well, it's not exactly an analysis result, but all of our analysis software, SAP, Revit, RAM, ETABS, are not great at visualization, and it's important to be able to see the data more intuitively to show it and also to respond to it and to understand the bigger picture. So we're kind of concentrating all that in Mirar, and we're working through different ways of visualizing. We even have it can compare models throughout in their history, see what's changed. In this case, you're just coloring by the attribute, it's basically like a different family, or I don't know if that's an adaptive component that came from Revit. But this is you can also send this exact view to somebody just as a web address. Spotlight I mentioned is where a visualizer for Revit data. It always shocks me that Revit doesn't have a great way of doing this. So we have this, that in this case you're seeing concrete totals by tons per level. It's a very simple kind of number to deal with, but you kind of never get a good picture of your model without this sort of breakdown of it. So you can see that level 1 and P1 have a lot more tonnage and concrete than the other ones. And then just other kind of random metrics, unique families, total concrete volume, steel weight, blah, blah, blah. Or the number of different families and the volumes per that, or thicknesses of slabs. In this case, there's this much of that slab, and it's this many instances. It's just a simple way to kind of break down your Revit model. And then Asterix, I think I have a video of this. This is a good one. Well, let me just explain what it is. We more made this for architects. It's basically an automatic framing generator for essentially any volume. You basically input the core and the volume, and it generates a really smart and optimized framing design with a fairly good estimate of sizes, which can get you tonnages for different options. So the point is you can be playing through different volumes, different massing models, and get actual pretty within a small amount of error cost essentially from tonnage. I'm just going to show that video. I think we're in beta now, actually. So it's basically, it starts in Rhino, and then it's a standalone thing that's linked to a web. So it's really fast too. So it's already generated the framing, and you can then just adjust it by your structural grid is kind of the main input. You can see X spacing, Y spacing, and floor height. Those are the main inputs that basically you have, plus the core and then yeah, and there's even more detail. Whoa, there's even more detail. Where was I? Yeah, and then comparing options, which is kind of our Design Explorer approach. If you guys haven't seen that, you checked out Design Explorer. It's like going through a sort of a larger solution space. Originally, it was made to use in Grasshopper, which will then like use all of your sliders to like make all the possible options and let you go through them and their outputs. So here's like the different inputs, like those spacings that I mentioned, XY spacing, size of the volume, and then the outputs, which is like total cost. And you probably have seen these. What are those called? This kind of graph becoming more and more common, I think. And then there's a whole other arm that are more focused into analysis modeling. This is that Google project. That's like, again, another presentation in itself. That and that's all I was going to show you. Thank you.
Of BArch is a really amazing viewer. How is set up the architecture of that? I mean, were you able to use view server or kind of formats that you use for the viewer?
Actually, I don't know. I don't know how they built that. I was around for the very beginning of it, and we were using 3JS, yeah, with JSON files and exporting from. Yeah, you're exporting a JSON from Revit. Yeah, I think that's still the basic function of it. Yeah. Anybody?
I'm curious. So a friend of mine sent me over to Design Explorer many months ago.
Mm-hmm.
Can you elaborate a little bit about that? And then second question to it is, can you elaborate a little bit about that sort of automatic framing generator and exactly kind of which things is how similar is to which things is not?
Yeah, sure. I can try with the elaboration on that. The Design Explorer, this is, let me go back. Yeah, this is not Design Explorer exactly, but it's the same thing. It's these parallel bar graphs, but you can see it on the website actually. We're on 2 now. Okay, so this is the output. You generate this from Grasshopper, and there's the tool called Colibri is the one that kind of gathers all of your data, all of your parameters all together, and outputs them, 1 to Excel, which gets you this, and then 2 your images, and also even 3D models. I think these might not actually be 3D models, are they? Yeah, each one of these is actually a 3D model you can look at. So the point is, you have a large amount of, a huge amount of possibilities in your solution space, and they all have different performances. In this case, we're looking at, glare inside the space or radiation. If you have, at this point, you kind of tend to have the software power to run all of that. So we have it run through all the iterations, do the analysis, export all the results, and then you can sort through your solution space by certain parameters so you can get a kind of range of things you want. Like for instance, here's your depth parameter, and if you want to say only look at things with like lower depth, like or 7 to 9 is the building depth that you are looking at. You don't want anything intense. So now you get a new only these solutions that are in there, and then you want to have only things that are oriented like I don't know, I guess that's south, and then you can see the performance of those, and they're or you can work backwards if you want to get only things that perform. So if we got rid of these and go back to all the buildings, if you want only, and I'm forgetting what these are, UDI. Do we have any sustainability people here? What's UDI? I forget that one. If you want only things with the, say, the highest percent of UDI, I guess what is that? Then you can reduce your selection set to only get a few, and then look at them and then kind of decide from there. Oh, this is also, by the way, these are looking at louver types and depths. I guess that was louver depth, not building, and then height, orientation, whatever. So now you've sorted down. So that's Design Explorer in a nutshell. And then Asterix it's generating the framing and then using it's running like essentially back of envelope calculations on what did they call it? A structural graph on to get basic loading and then sizing it from AISC standard tables. So you can get a general sense of the loads, not with like vibration and seismic, but yeah. I don't think it uses vibration, but that probably wouldn't be hard to do that. That might be too complex, but it's getting a general sense of the loads also because it knows the type. That's how it's getting the load by occupancy, and then sizing it. It can find the load paths and then size each frame. So it's a fairly accurate thing without seismic, I think. It's for very early, like comparing massing, and I think it's the most advanced version of this. Though we've always dreamed of it, it's the most advanced version and the closest to like this tool that we've had in a while. Yeah.
We have a question from online.
Mm-hmm.
Igor asked, what type of optimization methods and algorithms do you usually use for structural engineering? Do you have any custom-made workflows using algorithms not available specifically within sort of like the Dynamo Grasshopper environment?
Optimization. Well,
maybe, and Igor, if you want to maybe kind of correct me, but I'm wondering if you're asking more about the sort of database stuff and that you might have alluded to earlier.
Are you waiting for a response? Well, anyways, most of our optimization tends to happen with Grasshopper on the early side of the concept. So Dynamo exists a lot, mostly on the more production side, because when you're getting it into Revit, you're like already pretty far along in the design. That tends to be where we are. So I think the point is, and I know I've shown some things where we're designing, like the ones where we're designing the piers, or but usually the design happens in earlier, and if there's some sort of loop or optimization that's happening with Grasshopper and SAP or Karamba or something like that. But then like the real design after that, once you've narrowed things down, happens kind of more slowly and manually in a way, because the sizing of things is like, once you have your form finding done, then the sizing is a slower process, which can happen in Excel like I showed, or in these softwares, which then takes an engineer to kind of verify and go through and test. Yeah. All right, that's good with me then. Thank you.
And cool, thank you, Daniel. That was awesome.
Yeah.
And if anybody has any other burning questions, desires, just you can email us or I'll be on the chat for another few minutes. So if there's anything else, I'll leave this open for a sec. But thank you everybody for attending. And what time are you flying out? Cool. So there's time to take Daniel out on the town for a little bit here. So cool. Thank you very much, everybody, for attending, and we'll see you again in a few weeks. Thanks.